In this video I am going to have a look at graphing regions. So let's write the heading. Now the interesting thing is that when we sketch the graph of something like y equals 3, what we're really doing is drawing a one-dimensional line on a two-dimensional plane. What this one-dimensional line does is divide my plane into two sections, one up here and one below it. Now below it is all this region below, it keeps going, and above keeps going that way. So how can we describe these two regions? Well, above the line, all y values, any point above the line, doesn't matter where it is, all y values for these points are greater than 3. Below the line, doesn't matter where I put my point, all these points have y values less than 3. So this was for below, and this was for above. So if a question asks for you to sketch the region y greater than 3, we sketch the line y equals 3 and then shade in the region above the line. That's not quite right. Let's do this again. This time let's start by sketching y greater than, let's say, -1. So I start by -1, the line y equals -1. But notice I am not drawing a full line, I am drawing a dotted line. This is a little bit like when we sketch a solution on a number line. For example, if x is less than 1, then we put an open circle. If x is less than or equal to 1, then we color in the circle, we have a closed circle. It's the same case here. If I had greater than or equal to, I would draw a full line. But in this case, it has to be greater than -1. That means the -1 line, this line here, is a boundary, but it's not actually part of the solution. So where do I have y values greater than -1? The region is above the line. So I shade above the line. Let's look at another example. What about if the region that needed to be shaded was x greater than or equal to 4? Now that's going to be our boundary at 4, but this time it's a solid line because of the equal sign, which means the equals to 4 is an included part of the solution. So where are the x values greater than 4? Which points would have x values greater than 4? Well, clearly as I move to the right, all points will have x greater than 4. So we don't draw arrows as before, we shade the region. Don't forget to label your axes. So hopefully it's clear that to the right is x greater than 4, to the left x is less than 4. Things aren't always so clear-cut. Let's look at another example. What about if the question asks for you to shade the region where y is greater than x plus 1. So again, we look for the boundary, and our boundary is going to be y equals to x plus 1. So we know what that looks like. Let's sketch it. It's the graph of y equals x, shifted up 1. And notice again, I am doing a dotted line, not a full line, because I am missing the equal sign here. So the question now is, which side of the line do I shade? I am looking for y values that are greater than this function, x plus 1. The line shows the function, x plus 1. So let's pick a point. Let's pick x equals 0. It gives me y equals 1. Find y values that are greater than 1, and this at x equals 0. Well, all of these y values are greater than 1. Let's pick x equals 3. That would be 3 plus 1, 4. What y values are greater than 4? Well, all the y values up here. So you can see that above the line, just like before, indicates y values greater than the line, even though the line is at a slope. So now I shade the region above the line. Anytime the question asks for y values to be greater than a function, we sketch the function and shade above the line. Let's have a look at another example. Let's have a look at the question where we want to shade y less than or equal to x squared. So in this case, our boundary is going to be y equals x squared. Is the line itself, the curve, included? The answer to that is yes, because of the equal sign. So here's my y equals x squared. Now I'm looking for y values less than this curve. Less than implies below. So I am looking at y values that sit below the curve. Let's look at another example. What if the question asks for a region that satisfies multiple restrictions? For example, y has to be greater than, let's say, negative x squared, and y has to be less than or equal to, let's say 2, and x has to be greater than, let's say, negative 2. So I have 3 equations, so 3 inequations, and we want to find the region that satisfies all 3 at the same time. First one, y greater than negative x squared. Notice no equal sign, so dotted curve. Then y less than or equal to 2, so a solid line, and x greater than negative 2, so negative 2, dotted line. So let's have a look. Y greater than negative x squared. Greater than negative x squared would be moving up. Less than or equal to less than or equal to 2 would be down, and x greater than negative 2 would be to the right. So the shaded region would be region that sits here. And of course, if you don't have a highlighter, we shade as we did before. Let's look at another example. What if the question asked for x squared plus y squared to be less than or equal to 4? Now we hopefully recognize that this is the equation of a circle, and the circle, if I was going to do the boundary, would have a radius of 2. So here's a circle of radius 2. Now, what essentially this equation is saying is that the boundary is 2, and I'm looking for all circles which have radius. Remember, the right hand side's radius, but we are looking for circles where the radius is smaller than or equal to this radius, 4. So that would be any circle that falls inside this circle. And again, we have a full circle, not a dotted, because of the equality. Let's look at another example. What about if we wanted these two conditions both to be true? X squared plus y squared to be greater than 4, and x squared plus y squared to be less than or equal to 9. So the boundaries would be the circle with radius 2 and center 0, 0, and that has to be dotted. And a circle of radius 3, except this one is a solid line because of the equal sign. So let's mark in So I'm looking for circles with radius greater than 2. That would be going outwards. And also it must satisfy radiuses less than 3. So that would be going inwards. So the region that I shade would be between these two circles. And that's how we shade regions on a number plane.